Good morning. Today we are going to be working with permutation. Permutation deals with ordering, with arrangement. If I have a turtle, I have a little fish, I have a frog, a duck, and a dolphin. And I want to be able to find out how many different ways can I rearrange these animals. That'll be permutation. So for example, one way is to be able to have it the way I have them. Another way is to be able to have the fish first, then the duck, then the dolphin, then the turtle, and then the frog. So that's two ways. Another way is to be able to have the duck first, then the dolphin, then the fish, then the frog, and then the turtle. That's a third way. So how many different ways can I rearrange these five little animals? That deals with permutation. So let's go over the definition. Permutation deals with ordering. So an ordering of n objects is a permutation of the objects. For instance, there are how many permutations of the letters A, B, and C? There are 6. So let's go and write them down. The first one will be A, B, C. That's one ordering. Another one will be A, C, B. That's the second one. A third one will be B, A, C. A fourth one, let's start with the letter B once again. B, C, A. Can you write the last two? Go and pause it, see if you can write the last two, and then we'll check. Great. So the next one will be C, A, B, and the last one must be C, B, A. So you have 1, 2, 3, 4, 5, 6. In general, the number of permutation of n distinct objects is what we call n factorial. And the factorial is the little exclamation point, exclamation mark. So in this case, 3 factorial, that is 3 times 2 times 1, which is equal to 6. If it was 10 factorial, it will be 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Multiply them together, and that'll be 10 factorial. Let's go through example number 1. On example number 1, it says Maria has 5 homework assignments. And if you have a highlighter, go and highlight the information that's given, and that's going to be very helpful. So she has 5 homework assignments to complete this weekend. In how many different ways can she complete all 5 assignments? So how many different ways can she rearrange those assignments to complete them? So let's say that she has English homework, and history, Spanish, she has physics, and of course she has math. So that's 1, 2, 3, 4, 5. Because we know that we need to be able to rearrange all 5 of them. Many of you guys will write down 5 factorial. Another way of thinking about it is to be able to say, okay, we need to be able to complete 1, 2, 3, 4, 5. For the first part, how many different subjects do we have to choose from? So there are 5. So we can actually select to do 5, either one of those 5 first. So let's assume that you did your math first, of course. Now that you've done your math, how many are available for the next part? We have 4. So let's say you did your history next. How many subjects are available for the next part? We have 3. Let's say you do your Spanish next. That's 3. And for the next part, we have 2 subjects available. Your physics. And last, you only have 1 available, which is 1. You could have rewritten this as 5 factorial. So many times you guys will see this as an answer on a multiple choice test. So let's multiply it together. That will give me 20. And 3 times 2 is 6, times 1 is 6. Multiply together will give me 120. So there's 20 ways to be able to complete your homework. Letter B. In how many ways can you complete the assignments if you must do your math homework first? So if you must do your math homework first, how many different ways can you complete the rest of the assignments? So let's go and do our 5 dashes. 1, 2, 3, 4, 5. We know that math must be first, so we cannot move this one. This one must be completed first. So how many do we have to rearrange? We have 4, so we can do 4 factorial, and that'll be our answer, just expand it. Or we can think about the rest. If I did my math first, how many are available for the next spot? 4. Then for the next one will be 3, 2, and then last we have 1, which is the same thing as 4 factorial. Let's multiply it up. That'll give me 12, and that'll give me 2, so it's a total of 24 ways. Let's go through example number 2. On example number 2, it says, you are placing the pictures of each of your 7 family members on separate pages in your family album. How many different ways can you rearrange the pictures? So how many pictures do we need to rearrange? 7. So your answer can be just 7 factorial and then expand it. Or we can think about it just in terms of dashes. Of 1, 2, 3, 4, 5, 6, 7. How many pictures are available for the first spot, for the first page? We have 7. So now that you place one picture in here, how many are available for the next spot? Will be 6. How many are available for the next spot? Will be 5, then 4, then 3, then 2, and then 1. Or as you guys can see, it will be 7 factorial. So let's go and multiply it out. That gives me 42. That gives me 20. And 3 times 2 times 1 will give me 6. I'll multiply those two out. That gives me 84, and then I add 0. 840, and multiply by 6, I'm going to multiply on the side. 840 multiplied by 6, that gives me 0. 24, carry 2. 48, and 2 is 50. So it's a total of 5,040 ways that you can rearrange those pictures in your album. Now for letter B, how many different ways can you rearrange the pictures in the album if your little sister must be in the last page and your mom must be in the first one? Now since your little sister must be in the first page and your mom must be, your little sister must be on the last page and your mom on the first page, how many different pictures do we have to rearrange? How many are left? 5. So that way we need to be able to, we have 5 factorial as our answer, and then we can expand it, or we can just think of it as the dashes 2, 3, 4, 5, 6, 7. So your little sister must be on your last page and your mom must be on your first page. Now that you place those two pictures together, how many pictures are available for this spot? 5. For the next one, 4. Then we have 3. Then we have 2. Then we have 1. Or just 5 factorial. So if you guys feel comfortable with just doing the factorial, you can do so. Otherwise, you can go and just set it up and kind of think through the process. Now let's go and simplify it. So we have, this will give me 20. 3 times 2 times 1 will give me 6. Multiplied together will be 120 ways. So if you must place your mom first and then your little sister at the last page, the rest of the pages can be rearranged in 120 ways. Now let's continue to the back side. On the back side, we have, on example number 3, It says an ice skater competition features 5 different skaters. How many different ways can 3 skaters finish first, second, and third? In this case, we are only concerned about the first 3 that finish, not all of them. If we were looking for first, second, third, fourth, and fifth, then we can have a 5 factorial. Now, some of you guys might have seen this in a different class as a permutation problem in a notation as P5, 3. But in this class, we're going to simplify it. Just the whole concept, we're going to simplify it a bit more to make it a bit easier for the whole chapter. So let's assume that we have 5 different skaters. 1, 2, 3, 4, and 5. So let's go and assume that we have our 5 different skaters, and we have it here above. So let's go and place, we're only concerned about the first, second, and third place. So the first, second place, and third place. So if we have all 5 different skaters, how many of them are able to finish first? So how many do we have available for them to finish first? So we have 5 of them, right? 1, 2, 3, 4, 5. So let's assume of course, the little turtle finished first. Now, for the second place, how many are available now? How many are available to finish second place, or how many of them are capable? 4. So let's say the dolphin will finish second. Now, how many of them are available for the third place? Will be 3. And which one should we finish third? The ducky. Does that help? So hopefully that helps. So now we can just multiply 5 times 4, which is 20, and then multiply by 3 will give me, there are 60 different ways that we can have a first, a second, a third place out of 5 skaters. So either we can have, just like we had before, that'll be one way. Another way we'll be able to finish the dolphin first, the turtle second, and the duck third. Or we can have, that's another way. That's another way. And you can continue on. And if you do all the combinations that are able to do first, second, and third, will be 60 ways. Now, notice that the order matters. It does matter if we have a turtle, a fish, a frog, a fish, and then a turtle. Or if you have a frog, a turtle, and then the fish. The order matters on this type of problems. And we'll come back to the explanation later on.